Good evening and welcome. My name is Colin. My amateur radio call sign is KE8RXN, Kilo Echo 8, Romeo X-Ray November. And currently at time of recording in the year 2023, I'm recording this in the month of February as we look ahead to our severe weather season coming up in the spring and summer of this year for Western Lower Michigan. I serve as the assistant team leader for Kent County Skywarn. If you're not familiar with Skywarn, then I would encourage you to check out some of the other videos on my channel where you can get an introduction not only to Skywarn, but to the history of the National Weather Service, to other very important topics related to trained storm spotters, which is our purpose in terms of observing radar, and also other resources you can avail yourselves of as well. So tonight's topic is going to be weather station networks. Why are they important? Which ones do I recommend? And just some thoughts and considerations for utilizing these weather station networks in terms of accurately interpreting them and reporting your findings in terms of the readings you observe on the air. So with that, let's talk about 6 different weather station networks that I will rely on here. The first of which is not so much a weather station network as it is a weather map. So the first of 6 that we are going to speak of is Weather.gov. And the other 5 for reference are going to be the Weather Prediction Center homepage, the Weather Underground webpage, Ambient Weather, the Tempest Station weather map, as well as APRS.fi, the live APRS map of ham radio APRS stations, which includes weather APRS stations. So to begin, let's go to Weather.gov. And you can see here that I already have it pulled up in my browser. And on the homepage of Weather.gov, there is a great deal of information that you can find. You can look at forecast maps, you can look at radar, you can look at things such as satellite imagery, past weather, air quality, and additional educational and informational materials on Weather.gov. This particular homepage is useful in that it gives you a view of all of the current weather products issued by the National Weather Service for the CONUS. And if you're not familiar with the term CONUS, it's simply an abbreviation of the term contiguous United States. But as you can see, not only does it include the CONUS here, it also includes Alaska and Hawaii as well. If you are interested, you can also look at the products issued for American Samoa, Guam, and Puerto Rico, along with the Virgin Islands. So, what does this show us? This shows us all of the products that are currently in use. We can see, for example, along the Pacific Northwest, if we go ahead and click just offshore of Portland, Oregon, we can see the current products that have been issued by the National Weather Service Forecast Office in Portland, Oregon. Right now, offshore in the Pacific, they have a small craft advisory. There are some locations that also have a wind advisory onshore as well. To the northeast, in the northeast portion of the CWA, which is the County Warning Area, in other words, just the coverage area for this particular National Weather Service office, you can see that they have issued a winter storm watch for a potential winter storm that may be impacting this region. And finally, you can see in the eastern portion of their CWA that they have issued a high wind watch as well. So if we want to navigate back, we simply can go back to weather.gov or use the back button in our browser. And so you can see that it is relatively intuitive. You can just click anywhere within the contiguous United States or even in Alaska or Hawaii if you want and view the product information. So, for example, let's go ahead and click on Honolulu, Hawaii. And we can see what the National Weather Service Forecast Office in Honolulu has issued for the Hawaiian Islands. Right now, they have issued a small craft advisory for each of the Hawaiian Islands, with the exceptions of some portions of the south and southeastern portions of the western 2 islands. On the Big Island, they currently have a flash flood warning covering the eastern half of the Big Island, as well as a flood watch on the western portion of the island. And then you can also see as well that they have issued additional flood watches along with a very small portion of a winter storm warning in the higher regions of the Big Island in Hawaii there for areas that may be impacted by winter weather. Hawaii does indeed get winter weather in terms of the highest elevations. In fact, in some cases, I can remember recently there was a winter storm warning, a blizzard warning, actually, I believe, for wind conditions in excess of 100 miles per hour from a few months back on the highest portions of the Big Island. So, this is simply demonstrating that if you want to see the entire United States, including Alaska and Hawaii, you can click anywhere in this map and you can see what is going on in terms of what has been issued by the local forecast offices. Let's say we want to look at northwestern Montana, and we can see here that the forecast office in Great Falls, Montana has issued a statement that there is going to be accumulating mountain snow through this weekend, specifically in the areas of Marias Pass along US 2, Kings Hill along US 89, Deep Creek Pass and US 12, and Bozeman Pass along the I-90 corridor. And there is increasing chances of 2 inches or more snow accumulating through Sunday evening. So at time of recording, I'm recording this on Saturday evening, that would be within the next 24 hours. So they are just simply warning folks that if you are traveling along any of these routes in the mountainous regions of central and northwestern Montana, just be aware of periods of decreased visibility and so forth. Here you can see again their county warning area and the various products that they have issued, such as a winter storm warning, a high wind warning, winter weather advisories, a winter storm watch, a special weather statement, and also a hazardous weather outlook as well. To navigate back to our homepage here, let's look very quickly before we move on to our next weather map here and look to see what is occurring offshore of New England, specifically about 250 nautical miles offshore of Delaware, Massachusetts, Rhode Island, Connecticut, and New York. So we can go ahead and click on that product polygon offshore of that Atlantic portion of the country, and we can see that we have an NWS marine forecast issued for mid-Atlantic waters. And the primary concern tonight at time of recording is a gale warning with seas approximately 5 to 9 feet. And throughout the weekend, seas will continue to build upwards to about 10 feet, and then through Monday, through the rest of the week, seas may increase as high as 13 feet in terms of the wave height. So that is certainly hazardous for smaller craft and even for larger craft as well that are not prepared to navigate gale conditions. But for our area of interest, of course, we are going to look at southwestern Michigan, or as we residents here in Kent County and surrounding counties typically refer to it as simply West Michigan. It would be southwestern Michigan or western lower Michigan if you are not a resident of this area or a resident of Michigan. And here we can click on the Kent County area, and now it navigates us directly to our local Grand Rapids National Weather Service forecast office, and we can see the current products that are actively in motion. So along the Lake Michigan shoreline, we can see that there is a small craft advisory that has been issued. That is not at all uncommon for this time of year, being winter, of course. And we can also see that in the Bay Area that there is a hazardous weather outlook. If we're interested to see what that hazardous weather outlook is, we can simply click on that, and we can see that it gives us information regarding the small craft advisory along the western shoreline of Lake Michigan, western relative to our perspective. It would be the eastern shoreline of Lake Michigan if you're looking at the entirety of that body of water. But to us, the residents here in West Michigan, Lake Michigan, of course, is off to our west. And then we can also see that in the Bay Area that there is additionally a small craft advisory, and also in portions of Lake Erie, Lake Huron, and Lake St. Clair, that, of course, the small craft advisories continue. So that is how you can utilize the Weather.gov homepage to quickly gain information about any portion of the country, perhaps where you live or perhaps where you have friends or family who may not be as weather aware, and you simply want to know what is going on. And of course, we have to remember that weather functions in the mesoscale, or in the smaller portions of the country, directly as a result of the synoptic scale. Synoptic simply means a larger area of coverage. Mesoscale typically refers to a smaller area of coverage, such as the area of a state or something like that. So, synoptic weather typically refers to weather happening across the country. There is also global weather as well, too, which obviously impacts synoptic weather. And what happens on the synoptic scale impacts the mesoscale or the smaller scale as well. So there's a lot more information on Weather.gov that you can avail yourselves of if you want to navigate to that. I'll include all of the links to these weather maps and weather station maps in the video description, along with chapter demarcations in the video as well for easy navigation. So that is the first one that I recommend, Weather.gov. Moving along to the second one, we can navigate to the Weather Prediction Center. And that link is going to be wpc.ncep.noaa.gov, or you can simply Google Weather Prediction Center or WPC and find the information that way. So on the homepage of the Weather Prediction Center, it will first bring you to the Overview tab. And what this web page is for is it is used for synoptic forecasting. It's used as a launching pad from which to take your understanding of synoptic scale weather and what will be impacting large areas of the country, and then build your local forecast impacting the mesoscale from there. So we can see here that on the Overview tab, we have the National Forecast Chart. This will show you areas of high and low pressure and the coincident areas of cold and warm air associated with those. We can see, for example, that in the Rocky Mountain West, that we in portions of Montana and Idaho have areas of high pressure driving down that colder air from Canada that is generating various winter weather products. We can see along the coast of California and the Gulf of California stretching down into Mexico that we have warmer air lifting off the California and the Mexican plains that is colliding with the high pressure colder air in the Four Corners region of the country, producing various impacts that we can see that we already previously saw on the Weather.gov site. So this is a forecast chart that will show you up to 3 days out for the large scale synoptic features such as the ridges, the troughs, the cold and warm fronts, and the associated areas of high and low pressure. Now, there's a great deal more information on the Weather Prediction Center, and I would certainly encourage you to have this page bookmarked in your tabs of weather data. But the one that is specifically pertinent for live weather analysis is going to be on the Surface Analysis tab, the second one directly to the right of the Overview tab on the homepage. And we're going to be looking at the North American Surface Analysis at the latest weather information that we have available. So the information that we can see here, we can see that the issue date was Sunday, February 19th, 2023. It was issued at 0000Z or 0 Zulu hours. That would be 7 p.m. Eastern Standard Time here in Western Lower Michigan. And so this is the data as it was live approximately almost 4 hours ago. It updates about every 3 to 4 hours, so it's not entirely live, but it's close enough. Generally, these areas of high and low pressure and the attendant fronts generally don't move that quickly throughout the country unless there's a very significant weather event going on. But we can go back and we can see the overall pattern changes in the last 24 hours. We can see that there are troughs that are trying to dip down into the northern Great Lakes but are relatively stationary. And so as we continue to move along, we can see that there's a couple of areas of low pressure in the high plains in northern Nebraska and in northern South Dakota, southern North Dakota, where there is a warm front that is driving some warm air from the south. We call that advection, where a warm air mass is being moved in a particular area as it's being forced along by the colder air behind that. And so you can see here that these red temperature readings, those are the surface temperatures, and the green temperature readings, those are the dew points. So here in western lower Michigan, for example, we can see that the temperature at 00 Zulu time, or 7 p.m. local time, was a measured 37 degrees Fahrenheit with a dew point of 27 degrees. We can see along the warm front here in Nebraska and Iowa and central western Illinois, the temperatures are slightly warmer than that on the measure of a few degrees. They are in the mid 40s at time of analysis here. The other thing that I will point out regarding this particular map is not only can you see the fronts, you can see the high and low pressure centers, you can see the measured surface temperatures in red, the dew point temperatures in green. You can also see the wind barbs as well too. These are these blue wind vectors that are showing you the direction the wind is coming from. So for example, we can see that in the central southern US leading into the central plains into the northern plains, we can see that largely the wind flow is from the due south. If you're not aware already, we in weather terms refer to the direction that wind is coming from, not the direction that wind is moving toward. And so we call this a southerly wind because it is coming from the south. Obviously, the temperature is from the south straight to the due north, but we don't call it a northerly wind because it's not originating from the north. So that is going to tell you the direction the wind is coming from. These wind vectors here, they're always going to be pointing in the direction that wind is moving to, but nevertheless, we always refer to the wind direction as where it is originating from. And if we were to analyze this further, we would see that the pattern in the northern hemisphere of wind rotating anticyclonically around high pressure centers, meaning in a clockwise fashion, and wind rotating cyclonically or in an counterclockwise or an anticlockwise, a counterclockwise fashion around low pressure centers, indeed holds true. There is counterclockwise or cyclonic rotation of air mass around these low pressure centers, as well as a anticyclonic or clockwise rotation around these high pressure centers. So that is useful information if you need at a glance to see where the pressures are, where the fronts are, what the measurements in terms of temperature and dew point are, along with the observed surface wind readings as well. Again, there's a great deal more information that you can find on the Weather Prediction Center.gov webpage, and I would certainly encourage you to investigate that more for yourself. But for the purpose of reading live weather data to understand actual current measured weather conditions, this particular webpage is useful for getting a broad overview of measured weather along the surface at a glance throughout the entire country. So that is an introduction to the Weather Prediction Center's surface analysis in terms of the latest North American surface analysis that you can find. Moving along now to a weather station network, this is one of the largest ones. And this is Weather Underground, or as the URL is, wunderground.com. Again, that's whiskeyunderground.com. Whiskey simply means phonetically for the letter W. So, wunderground.com. There's a great deal of information, and that is an oft-repeated refrain I'm certainly using at this point, but there's a great deal of information you can find here as well. You can find local forecasts for any areas of the country that base it on actual surface measurements that it takes from private weather stations near your general area, as well as the best feature, the maps and radar and the sensor networks. Now, Weather Underground is an amalgamation of various private weather station networks. And what do I mean when I say private weather station networks? I simply mean they're not professional ones. These are consumer weather station networks that have been purchased through various stores, various web pages such as Amazon.com. There are various brands. They might be Ambient Weather, they might be Tempest, they might be a whole host of different varieties. And so when people link their data to weatherunderground.com, it shows you live surface readings for a whole host of parameters in terms of the sensor network and the maps and radar that it provides. So let's go to the sensor network tab And we can see that it gives us information on how to buy a weather station, air quality sensors. But what we want to look at is the weather station network. And again, this will give you an overview of how to join the network if you're unfamiliar with how to do that. You have to learn what a PWS is, a personal weather station. You need to find information on how to buy it, install it, and then register your PWS, your personal weather station, your private weather station, with Weather Underground. So this is not actually the map itself, but this page is very useful if you are not familiar with Weather Underground and how to register a station, let alone which station to purchase. You can find that information there under Sensor Network and then the Weather Station Network. So if we go to the Maps and Radar, the weather station map that Weather Underground provides is called the Wonder Map. Not WONDER, but WUNDER. So let's go to Wonder Map. It will take a second to load here. And if you have location services enabled, it will automatically load your location based on your IP address. Now, I'm running a VPN at the moment, and the external IP that I am using is based out of Chicago, out of that particular VPN server. And so you can see that it is loading the Chicago area for me because that is where my public IP is currently pointing. If I was using an IP in New York or in another portion of the country or the world, then it would simply load to that location. So if you happen to reside in that location, or if you wanted to know what the weather is if you're running a VPN in your VPN's location, then you could certainly let it load that location for you automatically. But obviously that's not all that helpful most of the time. So what we can do is we can simply drag around the map to find the area of interest that we want to analyze. We can use zoom tools, of course, to load larger portions of the country. And you'll notice that as the map scales, as we zoom in further, it will load additional weather stations. For example, if I zoom all the way into Kent County here, you can see that it has loaded more weather stations than what were previously visible on the larger scale. If I continue to zoom in even further, you can see additional weather stations are populating within the general area that I live here in Kent County. So you can navigate your way around just by wayfinding on the map using simple and intuitive navigational tools. But let's say you also want to pull up a particular location. Let's say I want to know what the weather is like in Granville. I can search for Granville, Michigan, which has a U.S. postal code of 49418, and you can see here that it will bring me to Granville, and as I zoom in, we can see the Rivertown Parkway corridor of 44th Street, along with the major I-196 artery, the Gerald R. Ford Freeway, and we can see the weather stations that are populating in the Granville area. So for example, if we want to look at these two particular weather stations on Navajo Drive, which is a side street in Granville, Michigan, we can simply click on either one of these weather stations and we can see what the current readings are from that data. So this one, with a station ID of KMI Grand 527, it tells us that the current measured temperature is 34 degrees. The wind chill is negligible because there are 0 miles per hour winds right now. There's no winds at the moment, and it feels like 34 degrees because of no wind chill. The dew point is around 28 degrees Fahrenheit. There was no precipitation today, with a atmospheric pressure of 30.15 inches of mercury. No impacts to visibility at the moment. No daily precipitation, as previously mentioned, with a humidity of 78%. Now, if we want to look at the adjacent station in that neighborhood as well, we can click on this particular station, which has a Weather Underground station ID of KMI Grand 620. And we can see that at the moment we have very light winds. We have a 1 mile per hour wind from the west-southwest with gusts up to 3 miles per hour as measured by the KMI Grand 620 weather station. This particular weather station is recording a surface temperature of 35 degrees, because the winds are so light as to be almost negligible. The wind chill is the same as the surface temperature at 35 degrees. The dew point is 29 degrees Fahrenheit. No precipitation for the day. The pressure is 30.08 inches of mercury. No impacts to visibility, with a humidity in terms of moisture saturation of 78%. But let's say we wanted to look at the graph for the KMI Grand 620 weather station. We can go ahead and click on the graph page, and we can see that it gives us a graph, an interactive graph that we can use to look at, in this particular parameter, the temperature and the dew point throughout the day. So we can see here that at approximately 1:30 a.m. today, which would be Saturday, February 18th, 2023, at time of recording, the surface temperature as measured by this particular weather station was 23 degrees Fahrenheit with a dew point of 19.2 degrees Fahrenheit. Throughout the day, as diurnal heating kicked in, we had a lot of sunshine today. We can see that temperatures rose from about the low to mid 20 degrees Fahrenheit to about a daily high of 40 degrees Fahrenheit around 5:30 p.m. local time, with an attendant dew point of 28.2 degrees. Now, let's say we want to look at more information, however, from this weather station. We can go ahead under the graph tab and click Visit Local Weather page if we want to see the weather specific to Grandville, Michigan. And we can find all sorts of information on air quality, the UV index, which is going to be extremely low to non-existent this time of year in our winter season. And we can see all sorts of information related to the almanac, to astronomy, such as the actual time, the civil twilight, the nautical twilight, the astronomical twilight, the length of the visible light, the length of day, the phases of the moon, and so on and so forth. But let's go back to this particular weather station, KMI Grand 620, and let's say that we want to view, as we zoom out on the map, we want to view surface readings that pertain to the wind. Now, the weather station field will already be checked, and the temperature and wind reading should be checked by default, but if you happen to see that it is loaded as temperature and it's not showing you the wind barbs, simply click temperature/wind. Now, if we wanted to see what the dew point was or the precipitation, we could always flip to that as well. So, for example, we can see that in my area in Kent County, the dew point is right around 28 to 29 degrees with a humidity of 81%. If it was an active precipitation event, and I wanted to see what was going on, then I can go ahead and click on precipitation, and I can see the daily precipitation for various weather stations throughout the region. Now, for those of you who aren't residents of Kent County, you wouldn't immediately know this, but these readings are not from rainfall. This is from snowmelt. So, for example, in Allendale, this particular weather station recorded 0.31 inches of snowmelt. And how that occurred is there would have been snow that accumulated on the weather station that then melted due to the diurnal heating, due to daytime heating, and that was recorded as precipitation. If you happen to be interested in the air quality, you can select that as well too. You can also load NOAA weather radar in terms of not only the past, but you can also load future radars based on various convective allowing models. If you don't know what a convective allowing model is, no worries, we'll cover that in other forecast videos that I release in the future here. You can also look at satellite imagery if you are interested in looking at aspects such as cloud cover. It will take a second to load. I do have a relatively fast internet connection here, but even so, the Wonder Map does take a second to load that satellite data, and you can adjust the opacity as needed. The two that I would recommend that you have checked would be the fronts and the wind stream. And I would recommend that we go back to the weather station field and check the temperature and wind readings to have the cleanest view and the most pertinent view for Skywarn analysis, here. So once we have the fronts and the wind stream selected, we can see where these fronts are. We can see that there's an area of low pressure in central and northern South Dakota right now. There's also an area of low pressure that at time of analysis was in west central Kansas, east central Colorado. What is really helpful regarding the Wonder Maps wind stream animation is it will show you exactly where the wind fields are generating from and where they are going. As a general rule, in the northern hemisphere, the winds will flow from areas of high pressure to low pressure, with the caveat that because of the Coriolis effect, meaning because the Earth is rotating, there's also wind will also flow from high pressure to low pressure at right angles. So we just have to keep that in mind. It's not necessarily a straight line. The Coriolis effect will impact that as well too. But we can see here that if we look at areas of higher pressure along the Gulf of Mexico, we can see that the wind stream is flowing from the due south up into the areas of low pressure along Sioux Falls and South Dakota at large. And so that is particularly helpful if you're trying to see what the wind or how the wind is behaving on a synoptic scale or a larger scale. But the good news is we can also see how the wind stream is behaving on the mesoscale as well too. And the animation, the colors will darken for these wind vectors here based on how fast the wind is moving. So we can see that onshore flow from Lake Michigan to the shoreline of Muskegon, Ottawa, and Allegan counties is again from the due south because the overall synoptic pattern is advecting warmth and moisture from the south. And the wind stream here, in this particular scenario, this wind stream is navigating towards a high in, or rather a low pressure center in west central Ontario. That is what is attracting that southerly wind that is sweeping across the entirety of the state of Michigan this evening. So I would recommend that you have the fronts and the wind stream enabled, and this will just give you very helpful real-time information of where the fronts are. For example, in a summertime event, there would very likely be areas of instability and turbulence along this low pressure center if this was a summertime event. And so if we were a North Dakota resident and we wondered to exactly where that low pressure center and the front is as measured by weather station data, then we could see that it is to our due south. Let's say, for example, we are a resident in Bismarck, North Dakota. We can see that it is still off to our due south and it isn't immediately impacting us at this time because it is right over the population center of Pierre, South Dakota. So that is an introduction to the Wonder Map. There is also, just quickly here before we navigate to our next one, additional parameters that you can have as well. You can have the NWS products listed, certainly useful, by checking the severe check mark. And so you'll see the various products that are currently active from the National Weather Service. In a severe summertime weather event, you could also have lightning and storm reports checked as well too. If you live along the coasts or areas impacted by hurricanes, then you can have these various options for active tropical storms, sea surface temperature, storm surge. You can have all of that enabled on the Wonder Map as well. If you happen to live in fire weather country, which is typically the Rocky Mountain West to the West Coast to the desert southwest of the United States, then you could have those checked as well. This time of year, there's not a great deal of fire weather that's currently ongoing at the moment. But you can have all of those parameters as you need based on your analysis. And again, as a quick reminder for Kent County Skywarn analysis during an activation or leading up to or even after an activation, I recommend that you have the weather stations with the temperature and wind data, the fronts, the wind stream, and also having the NWS products located under the severe check mark, all enabled as well for easy viewing. Our fourth web page that we're going to look at this evening is the Ambient Weather Station Network. Now, I will give you a caveat that I am an owner of an ambient weather station, And so I will have more data on my personal dashboard than what you will have access to if you do not own an ambient weather station. But nevertheless, you will still be able to see much of the ambient weather data without needing an account and without needing to purchase an ambient weather station. So this is my particular dashboard here. We can see that the measurements from today, we can see that the current temperature is a measured 34.5 degrees Fahrenheit with a dew point of 28.0 degrees Fahrenheit. It was 15.6 degrees warmer than it was yesterday, and with no wind at the moment, the wind chill is exactly the same as the surface temperature. Today's high was 39.0 degrees Fahrenheit, and today's low was 19.2 degrees Fahrenheit, with yesterday's high of 26.1 degrees Fahrenheit and yesterday's low of 15.8 degrees Fahrenheit. Overall, the weekly high and low was 55.4 degrees Fahrenheit and 15.8 degrees Fahrenheit, respectively. The monthly high and low was 55.4, so we set a monthly record here in this particular week of February as measured by this weather station. Not an all-time record, but simply a record for the month of February from the data that my station collected this particular week, as well as a monthly low of 4.8 degrees Fahrenheit. And the yearly high was also set this week as measured by my weather station, and the yearly low is 4.8 degrees Fahrenheit. Now, the reason that the monthly and the yearly high are basically the same at this point is because it is only February. Throughout the year, as more data is gathered by my weather station, then we will see more variance in terms of the temperatures and so forth. Moving on to the wind that it's currently measuring, we can see that we currently have no wind, 0.0 miles per hour, but we did have a max daily measured gust of 20.6 degrees, or rather 20.6 miles per hour from the direction of 39 degrees. We have no current precipitation active right now, but we did have snow melt of 0.12 inches as measured by my station. Overall, the yearly rainfall in January through February is 53.97 inches measured. Again, most of that, some of that is actual rain, but most of that would actually be snow melt as various snow events have come through and then melted. The temperature is currently 1016.4 hectopascals, which would be the same unit of measurement, is identical to millibars. If you're not certain of the difference between millibars and inches of mercury, no problem at all. You're welcome to research it on your own. We'll probably talk about it in another video. Currently, the temperature is slowly dropping as at a rate of 0.7 hectopascals or millibars per hour, but that's nothing to be concerned of. If we were seeing, say, 5 millibars or 10 millibars per hour, that would be very significant. That would indicate to us that the environment is becoming increasingly unstable. And there have indeed been times leading up to active Skywarn activations where I have used the ambient weather station network to look at surface pressure falls in real time to get an understanding of when the exact timing will be for impacts here in Kent County. We can also see additional information regarding the humidity, currently 78% humidity. There's also additional indoor information as well, which is really only pertinent to me, obviously, but it also shows us additional information such as the UV index, the phases of the sun and moon, solar radiation, and so on and so forth. Now, if you don't happen to have a weather station network with ambient, that's certainly fine. You can go to ambientweather.net and you can look at any number of the ambient weather stations. Now, I recommend, because it will very likely put you in the middle of nowhere when you first navigate to this particular weather station map, is go ahead and just search for your location. So I'm going to go ahead and search for Grand Rapids, Michigan. And here we can see Grand Rapids, Michigan. It gives us an overview of the current temperature and weather, 34.2 degrees, mostly cloudy with partly cloudy tomorrow. Then we can look at the 24-hour forecast if we are so inclined. But what I want to do is I want to scale out and I want to look at the thermal gradient, which is simply a fancy way of saying I want to look at the variations in temperature as measured by these various weather stations. Now, I can see the temperatures, but I don't really see a color gradient, and that's what I want to see. I want to see that thermal gradient visualized for easy analysis. I can go ahead and click the thermometer icon, and there are two very useful features that it immediately presents. The first is it will use colors to show you the variations in surface heating at the moment. Obviously, the darker blue colors indicate colder temperatures, and the lighter ones indicate the warmer temperatures. Certainly very intuitive. If we zoom out of the West Michigan area, we can actually see the thermal gradients for whatever scale we want to look at. So now we're currently looking at the synoptic scale, and we can see the thermal gradients changing colors as we are now looking at, for example, the Gulf Coast. We can see those yellows and oranges leading into reds just offshore of Miami, because the temperature in Miami right now is about mid-60s, which actually it's about mid-70s, which is certainly much preferable right now to 34.2 degrees. But, you know, as a resident of West Michigan, we do get severe weather, but we don't get hurricanes. We don't get major tornadoes all that often. Usually we only get those once a lifetime here. We don't get earthquakes. So I can't really complain. Winter weather is our most impactful season, actually, in terms of the concerns from emergency management. If you read through our emergency management documentation for Kent County and surrounding counties, we do get summer severe weather events, but they're not generally as severe as other portions of the country. All that having been said, in a live Skywarn activation or leading up to it, such as if we're on what we call command and control, where we're actively monitoring the weather situation, but not yet activating, this is very useful information to utilize. I will say, I mentioned that it gives me two powerful features, one being the thermal gradient as visually represented by the changes in colors. The other is it will show you what the max and min temperatures are for what you are currently viewing. Now, here is a caveat that I will give with looking at any weather station. So let's go, for example, we can see we've got a weather station measuring 67.3 degrees in Portage, Michigan. None of the other weather stations in that surrounding area are remotely close to that. Most of them are 30 degrees less than that. So for whatever reason, this particular weather station is reading very high. It's an anomaly. We know the surface temperature is not actually 67.3 degrees Fahrenheit across western lower Michigan, but this particular station is reading that. The minimum temperature that is reading in this area aligns with the average surface temperatures that other stations in the area are reading. But if we zoom out, we can see we have another weather station that's reading at a very cold 11.3 degrees Fahrenheit in Schoolcraft, Michigan. But again, if we look at surrounding weather stations, we can see that, again, they are right along the current average of a measured 37 degrees Fahrenheit. So, for reasons unknown to me at this time, this particular weather station in Schoolcraft, Michigan is registering significantly lower than surrounding stations. So that tells me that these two particular stations are giving anomalous readings, and so the strength of these weather station maps is to look at surrounding weather stations and not rely on these two particular anomalies, such as this one 67.5 degrees Fahrenheit and this one 11.3 degrees Fahrenheit. We can see what the actual surface temperatures are as we look at more in the surrounding area. The same will also go for wind speeds as well too. We can go ahead and select our wind speeds, and this is probably the single most important aspect of using weather stations for Skywarn, is that you can use these weather stations as if they were spotters in terms of the wind speeds that they are measuring. So we can see along the I-94 corridor here and the US 131 corridor in Kalamazoo County that for the most part winds are relatively light out of the due south, around 6 to 10 miles per hour. We do have some areas where winds are gusting slightly higher than that, but nothing remotely concerning whatsoever. We can see that in South Haven, Michigan, along the US 31 corridor, that we do have some winds measuring closer to 15 miles per hour as measured at the South Haven Airport by their weather station, but again, that is not at all concerning. If we navigate farther north and we go into Ottawa County, we can see that the Holland Airport weather station is measuring winds measured 14 miles per hour from the due south, from the slight south-southwest, as well as gusts measured at 24 miles per hour. This is very useful during a Skywarn event because here in Kent County, if I want to know what the actual measured wind speeds in terms of the gusts are, and very quickly, the difference between wind and wind gust is wind is that the speed that is sustained for 60 seconds or a minute. A gust would simply be shorter than that, would not be sustained for 60 seconds or longer. But nevertheless, a short, strong, severe gust of wind can certainly cause significant impacts. So if I want to know what the winds are coming offshore of Lake Michigan, let's say we had a storm system moving offshore, as is very common along the U.S. or rather Interstate I-96 corridor. Let's say I want to see what the wind speeds are currently in the Zeeland area. And at the moment, they're only 1.8 miles per hour from the west-northwest. That's certainly nothing to be concerned of. But if I was seeing wind speeds of, say, 60 miles per hour, which I have in Zeeland, and I know from looking at radar that the storm is currently over the Zeeland area, and that storm is moving in from the southwest and is riding the I-196 corridor, the Ford Freeway, and will be impacting shortly portions of Kent County, such as Granville, Wyoming, Kentwood, moving into downtown Grand Rapids. If I can see that this particular system is already producing measured wind speeds of severe criteria or even sub-severe criteria, then I know that we need to take action, and I will inform my team leader accordingly of what I am currently seeing so he can make the decisions regarding whether or not we would need to activate. And if we saw measured wind gusts of 60 miles per hour in Ottawa County, very likely they would be in a severe thunderstorm warning if there was a storm, or a high wind warning if there was not, if they were non-convective severe wind gusts. And provided it was a severe thunderstorm, we would very likely already be activating at that point in time. And if not, very likely our team leader would make that decision to activate based on those surface measurements that we are seeing. The other feature that I will show you before we move on to our last two weather stations here is the radar feature. And this can be useful because this can show you lightning data, and it can also show you precipitation as well too. Generally in western lower Michigan, we don't usually have to worry about flash flooding, which is more severe than a general flood warning. In Kent County, and in fact many counties in western lower Michigan, we have as a main waterway the Grand River, which begins here in Holland and then traverses, meanders up through Kent County from the southwest, moves around the city of Grand Rapids, illustrating how major cities generally are always started along the banks of major waterways, and then continues to move off to the east towards Lansing, our state capital. If I was concerned about torrential rainfall, then I could see the live rainfall data that is being picked up. Generally, a flash flood warning is driven by rainfall rates of 3 inches or more per hour. Now, a flash flood warning is devastating. That can sweep away cars, that can sweep away structures, and so forth. But again, that's not really something that we worry about here too much in western lower Michigan. Other areas such as the Four Corners region or the desert southwest of the United States, where they have a monsoon season, they can get raging rivers and floods in literally 30 seconds. I've seen it happen. And so they have to be concerned about that kind of flooding. Generally, the concerns we have with flooding in our area have to do not so much with severe weather events, but with snowmelt and the expansion of ice along the Grand River in terms of our local main waterway. But those are all features that you can avail yourselves of, and the various usages that you might need to call upon them for leading up to and during a Kent County Skywarn activation. Let's now move on to our fifth weather station map, and this one is the Tempest station map. Now this one here, you can see that as we navigate to the TempestWX.com page, we click on map and it loads the station map that we can see all of these Tempest icons loaded here. It's very cluttered, so what we want to do, and I will say that this particular map is not as useful as Ambient because it doesn't show you the station readings right away. You have to click on each individual station to actually see the data. But let's say we want to go to Granville just north of 44th Street and Rivertown Parkway. Let's look at this particular station along Navajo Drive. This particular station, we can see the current timestamp, 11:28 p.m. This is when the data was recorded. The air temperature is 35.1 degrees measured. The station pressure is 29.359 inches of mercury, but we always refer to atmospheric pressure in terms of the sea level pressure, not the raw pressure reading. And so that is going to be adjusted as 30.062 inches of mercury. Relative humidity of 78%. We can see no rain accumulation today. We can see wind speeds currently of 1.6 miles per hour from the direction of 242 degrees, which would be from the west-southwest approximately. Light wind gusts at 4.3 miles per hour. We can see no solar radiation, no UV index, no luminosity because it's currently nighttime that I'm recording this. We can look at, if we want, the lightning strikes that this Tempest station has recorded. This is a very useful feature of the Tempest weather station, is that it will not only record lightning strikes, but tell you their approximate location. There were two in the last 4 days, approximately 17 to 20 miles southwest of this particular station. And it will give us additional information as well, especially if you are interested in the wet bulb temperature and the delta T temperature at 32.7 degrees Fahrenheit and the delta T of 2.3 degrees Fahrenheit respectively, along with the air density as well too. So the Tempest weather station map is not as useful as Weather Underground or Ambient. The weather stations themselves are certainly better than Ambient, but nevertheless the weather station map is not as useful because you have to look at each individual weather station to actually get the reading. You can't see a summary of particular parameters, such as flipping back here to Ambient, of the rainfall, the wind, or the temperature on the mesoscale or synoptic scale. The Tempest station map does not provide that information, but nevertheless still useful to know. Our last one is going to be a unique weather station map that not many would necessarily think to refer to, but it's certainly very valuable because these stations don't necessarily always require internet, and many of them are battery operated to provide data. And this is the APRS.fi map. What is APRS? Well, APRS is a ham radio term that refers to Automatic Packet Reporting System. And the .fi top level domain, this is a website based in Finland, but you can look at data all over the world. So this is my particular station here. You can see it's registered under my ham radio call sign, and you can see that it's giving you the measurements from my particular station, which we've already covered a few times, so I won't repeat that here. If I want to drill down further, I can click on that particular call sign here, and let's go to show weather charts. And here you can see the graphs of the APRS station data that my weather station has reported throughout the day. So you can see, of course, once diurnal heating kicked in, that the temperature maxed out at approximately 39 degrees Fahrenheit measured today at 1600 hours. We can see the humidity, we can see the pressure as well. Pressure for the most part was around average. It started slightly low at 1016.6 millibars and then peaked at approximately 1800 hours today at around 1027.3 millibars. Again, same unit as hectopascals, different completely than inches of mercury. We can see the wind direction. We can see the wind data as well, and we can also see the rain, which again, as a caveat I've mentioned, would refer to the snow melt from today. So the APRS.fi map, if you don't have a particular station already loaded, let's go ahead and clear this. And what you're going to see is you're going to see all the APRS station data loaded. APRS is used in ham radio for a wide variety of things. It's used for real-time location tracking, it's used for weather data reporting via ham radio, and it's used for a lot of different data reporting features. Anything that can be reported over packets via radio waves, APRS will be utilized for that purpose. When you are looking at this particular map, the weather stations are the ones that are the blue circles with the white WX, the white whiskey X-ray in the center. Those are the weather stations. So for example, this particular weather station, as maintained by ham radio operator Kilo Delta 8 Delta Lima Papa KD8 DLP, we can go ahead and look at this operator station here. We can see a summary of the measurements, and we can go ahead and look at the surface weather charts for this particular station as well too. Just to navigate back now to the home page, if you're not a ham radio operator, a lot of this data isn't necessarily going to be useful or interesting to you, but again, just remember the blue stations, those are going to be your weather stations. And so that information is going to be very useful to track if you're trying to get real-time analysis leading up to or during or after a Skywarn event. And so as I wrap up here, how do we think about weather station maps? Weather station maps will report measured, verifiable surface data with, of course, the anomalous station thrown in the mix every so often that we just need to be aware of from time to time to make sure we're reporting accurate measurements. But weather stations can function as limited spotters. And I say limited because they can measure temperature, they can measure a whole host of surface readings. What they can't do is they can't tell you cloud features or anything of that nature that an actual human spotter can do. But because there are far more weather stations than human spotters, I would recommend that you avail yourselves of all of these resources during your Skywarn endeavors. The Weather.gov homepage, the Weather Prediction Center Live North American Surface Analysis Map, the Weather Underground Wonder Map, the Ambient Weather.net Weather Station Network, the Tempest Station Map, and the APRS.fi weather stations as reported from ham radio operators. All of these websites will give you the data that you and others need to make decisions in the moment in order to decide whether or not to activate. I will say they will give you limited data. They will give you, of course, wind speed and temperature. They, of course, will never replace human spotters who can tell you features such as wall clouds, funnel clouds, tornadoes, shelf clouds, and so on and so forth. But they are extremely valuable, and I highly recommend that you use all of these resources. So, with that, this is KE8RXN, Kilo Echo 8, Romeo X-Ray November, Colin, the current assistant team leader for Kent County Skywarn, saying 73. That is a ham radio term simply meaning good wishes. And I will see you in the next video. So long. Have a great night.